Welcome to Math 1301 for our Monday lecture. We're looking at some items in the metric system and conversion from metric to English or English to metric. The section we're in is chapter 7.3, and in this section it begins, it's kind of a weird mix. It has both mass and temperature. And in the area of mass, there's some discussion about conversion from kilograms to pounds or pounds to kilograms. For the record, this is a bit odd for someone with a physics background because pounds is a measure of force and weight then is a mass times gravity, which equals pounds or a force. Whereas on the metric system, we convert from kilograms to pounds, which is weird because on kilograms, that's just mass, and the force in the metric system is the kilograms times the acceleration due to gravity, 9.8 meters per second squared, to give us a different unit of measure, which is newtons. So really, the conversion should be newtons to pounds, and kilograms should convert to the mass on the English side. Well, the mass on the English side is actually not in pounds, but in slugs. So it's a bit odd. Now the reason we get away with going from kilograms, which is a measure of mass, to pounds, which is a measure of force, is because the gravitational pull on Earth is universal, 32 feet per second squared, or if you're on the metric system, 9.8 meters per second squared. If any of you ever took physics, that 9.8 meters per second squared measurement might sound familiar to you because it shows up in everything in a physics class. But the reason we get away with just converting from kilograms of mass to pounds of force is because of the universality of the acceleration due to gravity. It's generally 32 feet per second squared, or 9.8 meters per second squared, everywhere on the planet. Now, we'd be in a different situation. If we went to the moon, we could not have this conversation. We'd have to change the conversion because the kilograms would stay the same. 10 kilograms on Earth is 10 kilograms on the moon, but the force due to gravity would change. And the pounds then would have to be changed because the pounds on Earth are not the same as on the moon. So the idea of mass is the amount of atomic material that makes up a human or an object. And the idea of pounds or newtons is the force due to gravity. But since there's a universal constant, we just speak as if these are measuring the same thing. Really, slugs go to kilograms and newtons go to pounds. But, and normally this really isn't an issue anyway. You go to the doctor's office, the only way this really comes up is that they are concerned about conversion because most of the medical world, in the terms of pharmaceuticals, talks about your mass and in terms of kilograms so that they can determine how many milligrams of a particular medicine you should be taking per kilogram of mass. And so there we see it. Doctors all the time, they weigh you in, and when they put it in, it converts it to kilograms for them. And then when they go to prescribe something, the pharmaceutical company has a formula. And a lot of doctors, it's already programmed into their software, but some of them are doing math throughout the day to figure out how many kilograms for a medicine that's not normally prescribed. They might do some math and quickly determine, well, there's a 50-pound kid, well, that's a 20-kilogram kid, and that means this many milligrams per kilogram, and so then to prescribe it that way. So this section includes a section on mass, but most of the discussion, there's not a lot of conversion. There's a few questions on conversion, and we'll see those, but most of them are just conceptual. What is this mass in kilograms versus pounds like? And so how much does a border collie weigh in kilograms? How much does it weigh in pounds? Now, the other part of this chapter, which is a little bit odd in that you have this section on mass, and then right next to it in the same chapter and section is this discussion of temperature. Now, temperature in the realm of the metric system, they use what's called Celsius. You guys are familiar with this. And Celsius is very scientific in that it takes a liter of water and says, at what temperature does that liter of water freeze and become ice? And they also take this look at Celsius and say, at what temperature does this particular liter of water, does it come to a boiling point? And they decided to divide this between 0 and 100 in order to have a nice even scale. Remember that in the metric system, everyone's obsessed with divisible by tens and hundreds. And so they did the same thing with temperature. They said we need to divvy it up the same way we do centimeters and millimeters and so forth. And we'll make it divisible by tens or hundreds, in this case, hundreds. So 0 is freezing, 100 is boiling point. Fahrenheit is really a measurement between 0 degrees where I'm super cold and 100 degrees where I'm sweating. It's not particularly scientific, but that's kind of the approach here. And so there's a conversion system here. And so we'll look at just a few questions. And from the book, so number 38, for instance, asks this question: 80 degrees Fahrenheit is equal to how many degrees Celsius? So what we do here is we're given Fahrenheit, but we want to convert to Celsius. This is what we want. We want Celsius. So we're going to go to this formula, the Celsius formula. We've got Fahrenheit. We need Celsius. And if you look at the formulas, you'll see they're just reverse of each other. I could subtract 32 from both sides. I get F minus 32 equals 9/5 C. Multiply through by 5/9. I get 5 over 9 times this subtraction, F minus 32, or Fahrenheit minus 32. So if we're going to find Celsius, we go to this formula. See, Celsius, I need this formula. So this is 5 over 9 times 80 minus 32. And you're going to put it in your calculator. You're not going to do this by hand. You're going to put it in your calculator. And you'll find out that this equals 26.67 degrees Celsius. And then number 40, similar question. Number 40, we have minus 10 degrees Fahrenheit. Now you got to be careful when there's negative signs here, but we're going to convert it to Celsius. And again, we're going to go to this formula. So we'll find that 5 over 9 times minus 10 minus 32. So be careful here. We have two negatives. All right, and so that is minus 42 times 5 over 9, and this will give us minus 23.33 degrees Celsius. Repeating, but that's close enough. All right, number 42, another problem like it. This is 100 degrees Fahrenheit, which, as you know, would be a very warm day in the state of Texas. Not out of the ordinary, but pretty warm for the month of July or August. And we're going to convert again to Celsius. And so we'll do 5 over 9 times 100 minus 32. And so you get 68 times 5 over 9. And this will equal to 37.78 degrees Celsius. And so quite a warm day. And so now we're going to go the other direction. So those were convert from Fahrenheit to Celsius. And we're going to, Celsius is the desired outcome. So you see this, we're looking for Celsius, so we're going to use this formula. Now on the other side, we have this conversion from Fahrenheit, from Celsius to Fahrenheit. So this would be helpful if you're traveling in Thailand. And that leads me to the first hint or clue that you have to email me in order to receive bonus points on your next test. If you can email me the nation or that I've just mentioned, Thailand, if you'll email me that for this video to prove that you actually watched this video. So there you have it. All right, so number 44 is minus 4 degrees. In this case, we're given Celsius, and we're going to convert it to Fahrenheit. So this is 26.67. This is minus 23.33. This is 37.78. And now we're going to go the other way. And so now we're going to put it in this formula. This is 9 over 5 times minus 4. Again, be careful. Plus 32. So minus 4 times that, that's around minus 7 or so. And we wind up with a temperature of 24.8 degrees Fahrenheit. 24.8 degrees Fahrenheit. Quite a chilly day in Dallas-Fort Worth. That's a day that you'll want to stay inside by the fire if you're a true Texan. That is too cold to be outside. All right, 46 we have 70 degrees Celsius, and we want to find out how warm that is in Fahrenheit. Now, 70 degrees Celsius, I hope you never experience this in real life. I suspect there's somewhere in the world has gotten this hot, but I would not want to be there when it happened. So we have 9/5 times 70 plus 32, so 9/5 of 70, that's like 126 plus 32. This is 158 degrees Fahrenheit. Now again, I suspect somewhere on the planet may have experienced this, but I would not want to be there for it. All right, so that's that one. And that leads us to the last one here, number 48. We'll do 48 as our last one. So this is 50 degrees Celsius is equal to how many degrees Fahrenheit? 50 degrees, still warm, but this one has been for sure experienced. In fact, I'm almost sure I have been somewhere that's been this hot before. So this, oh, actually, this isn't that. Let's see, 50, was that 10? 90 plus 32, so 122 degrees Fahrenheit. That's a pretty warm day. I'm almost sure that I was in Calcutta, India once that got to 50 degrees Celsius. And I was in the airport with no air conditioning. It was miserable. But anyway, so this is how you do the conversion of temperatures. If we want, we're given Celsius, we want Fahrenheit, we use this formula. If we're giving the Fahrenheit and we want Celsius, we use this formula. All you really need to do is look here to see, if I'm given the Fahrenheit, I'm going to plug it in this formula so I can get Celsius. If I'm given the Celsius, I want to plug it in this formula so I can get the Fahrenheit. Now, I would practice a few of these. There's some on the homework, but really, these should be easy points on the test. You'll be given the formula. You don't have to memorize it. All you have to do is plug in whichever formula you need to plug it in. So there's two ways people make mistakes on these problems. Number one is by either just putting it in the wrong formula. Inexplicably, they will put trying to solve for Celsius and plug it in the Fahrenheit formula. Don't do that. You're looking for Celsius, plug it in this one. The other thing people will do is make just a straight computational mistake. Not good with the calculator. That's why I'd practice and make sure you could do it. So if it were me, I'd probably try to match these 6 numbers real quickly and just make sure you can match them. Easy enough. You can pause the video and you can check them and make sure they match. All right, so that's video number 1. I'm going to make a second video. That way both videos are short enough to where they easily go on YouTube. So that's video number 1.